Good morning, everyone. My name is Aubrey Pomorsky, and I am the project manager along with one of the structural engineers with Jake Engineering. With me today, I have Jonathan Bone, our water resources engineer, Kenzie Kahn, our transportation engineer, and Emil Friesville, our other structural engineer. Our project is Eastgate, which is located across the road from Gellerson. And our goal of this project is to design 2 buildings that our structural department is responsible for. And these buildings will be in the yellow rectangle and the blue rectangle. And will have the purpose of being an academic building and the other being a residential and retail building. Our transportation department will design a parking lot to accommodate these buildings and a road that connects Sturdy and Silhavy Road as shown by the red dotted line. And then our water resources engineer will design the drainage and water treatment for all of the runoff from these new developments, along with a culvert located at the east side of the property so that the road can fully connect. And now I will pass it on to our transportation engineer, Kenzie Kahn.
Thank you. As Aubrey said, I am Kenzie, and I am the transportation engineer for Jake Engineering, and I have been tasked to design the new roadway, the redesign of the 2 intersections for these roadways, and then a parking lot for the new buildings that will be placed. So I'm just going to give a brief summary over my alternatives I have designed for the semester. My first alternative is a roundabout. My second one for Sturdy Road is a signalized intersection. And the third one is a 2-way stop. For each of these, they were designed with the City of Valparaiso specifications in the NDOT manual and then the AASHTO Green Book. As you can see, these intersections also include a crosswalk to connect with the campus and then a sidewalk that will connect below my road alignments. As you can see from my Silhavy Road intersections, I have a T intersection, a signalized intersection, and a roundabout. So as you can see, I did design 4 alternatives for my road alignments. The last one was eliminated just because of the existing road conditions or of the soil and what it is in shape right now. So for my first alternative, I did choose to go along the existing pavement, which is right here, and it will connect below Boilermaker Court. So my second alternative does connect to Boilermaker Court, and then my third one is above Boilermaker Court. As you can see, I have 300-foot radiuses for my second and third alternative, and for the first alternative, I did do 500-foot radiuses just because the pleasing the public and just like the aesthetic overall. Each of these, the 5-foot sidewalk will be placed south of the alignment. From here, I did do a rating rubric for my each alternative. As you can see, I base this on the effectiveness, the cost, the utilization of space, the aesthetics overall, and the cost, and then the public impact, and then the level of service, which is only for the intersections, just due to it being a big part of transportation planning is the level of service. As you can see, I did rate each of my alternatives. For the Sturdy intersection, the one that did come with the highest rating is the signalized. For the Silhavy intersection is the T intersection. And then for my road alignments, I did pick the one that is below Boilermaker Court. So this is good because the T intersection does have 3 approaches, and since this road alignment is below, it only has 3 approaches, so it did work out. So here we can see the model of my signal. Of course, the northbound and southbound directions will have a higher volume just to do more traffic, so the green cycle is longer. For the eastbound and westbound directions, I have a green left turn lane just because it is hard to turn left there, so I did give them the green light, and then in addition to the straight and right are included in that. For my next chosen alternative, I did pick a T intersection. Here you can see the stop sign is for the eastbound direction. The northbound and southbound do not need to stop, just because it's higher traffic flow and there is enough time for the eastbound direction to stop accordingly. And then finally, I do have my last alternative, which is the road alignment, which is below Boilermaker Court. As you can see again, the 500-foot radiuses. And then this below is my horizontal alignment, which will be placed where the culvert area is. This area right here is where the culvert, just because of the stream, so we did need to place a culvert there, which will be designed by our water resources engineer, John Bone. And then from here, this is my parking lot. I've said in my progress presentation, it is designed for 219 spaces, 7 of which are handicapped, 2 of which are van spots, and then 2 bike racks. So here is a full CAD design of my alternative. So as you can see the intersection, the parking lot, the 2 500-foot radiuses, and then my Silhavy intersection. And finally, my cost of this chosen alternative is around $5.5 million. As you can see, we did have to include demo in this because there was existing pavement, and we did have to include excavation for the areas that the roadway is going to go. And then for my future work, I have CAD design. I'm going to do some standard plans, a provision of the pedestrian facilities, which would be the sidewalk and the crosswalks. And then I have, I'm going to spend most of my time on the plan and profile sheets, and then after all of this is done, I will do a final cost estimate. And now we will hear from our first structural engineer, Emil.
Thank you, Kenzie. As one of the structural engineers, I am in charge of designing the retail and residential structure. I'm considering 3 different alternatives, all of which will have 12,000 square feet of retail space, 24,000 square feet of residential space, and 2,000 square feet of covered outdoor spaces. The first alternative is a 2-story steel structure that follows the layout as we see it here. On the first floor, we'll have retail space and residential space. The second floor will have additional residential space, as well as a rooftop patio providing the covered outdoor spaces. Taking a quick look at the structural layout, this was determined using rules of thumb for steel design, as well as making certain assumptions about the dimensions of structural members. As you can see here, the blue ones are the girders, and where they intersect there will be columns, and in between by the orange or yellow lines, those are the beams. The second alternative is a reinforced concrete structure. As you can see, it follows the same layout as the first alternative. The structural layout is also very similar. There are some slight variations, as here we're using rules of thumb for concrete design, which based on the material properties, there's going to be some slight variations in span lengths and so forth, which is more apparent when looking at the 2 alternatives side by side. The third alternative is a 1-story steel structure. It follows the layout as you see it here, where in the middle, that's where the covered outdoor spaces will be, as well as room for a garden area. For the structural layout, we follow the same procedure as for the first alternative, and get the structural layout as presented here. For ranking the alternatives, we're looking at key parameters such as cost, aesthetics, construction, and accessibility. For the cost, we're looking at how well each alternative compares relative to each other, meaning that the most expensive alternative receives the lowest score, cheapest receives the highest, and so forth. For the aesthetics, we're looking at how well each structure is going to tie into its surroundings and how well it fits with these structures already on site and in the immediate neighborhood. For construction, we're looking at how easy or difficult the construction process is, meaning that a more difficult or lengthy construction process would receive a lower score. We're also looking at accessibility. We thought this was important as we're designing for senior citizens, and we want them to be able to maneuver the space easily, be able to get around. And we also want to make easy access to the retail spaces for the public. Each of these parameters is weighted on a scale of 1 to 4, with 4 being the highest. This goes to the cost, as we think the cost is the most important parameter when evaluating the alternatives. Looking at the first alternative, you can see it gets the perfect score for cost, as this is the cheapest alternative. It doesn't do too well in terms of construction, as it is relatively the harder or more difficult construction process. The second alternative receives the lowest score for cost, as it is the most expensive alternative, and it also doesn't do too well in terms of aesthetics, as we're afraid that a 2-story concrete building is going to look too out of place in the area. The third alternative, the 1-story steel structure, receives the highest overall score of 41. This means that this is the alternative that we will start to expand on and move on in the design process. The chosen alternative does really well in terms of accessibility with the 1-story layout. Makes it super easy for residents to get around and access the common spaces. It also makes it easy for the public to access the retail space, as it's located right adjacent to the parking lot. Aesthetically, the 1-story layout also ties better into the surrounding areas and existing structures on site. And if you take a look at the cost, you'll notice there's a demolition cost attached to this structure. This would have been the case for no matter which alternative I pick. That is because the new design is going to require to take up some of the space where there's already existing structures on site. Adding the demolition cost to the total overall cost found by RS Mean gives us a cost for this structure just above $7 million. For the future work, we can now start to expand on the design I showed earlier and dive deeper into designing individual members in the structure, and this will eventually lead us to make a more thorough cost estimate in the end that's going to be more indicative of the final cost after construction is done. And I'll pass it over to John, who's going to talk about water resources.
Thanks, Neil. So to recap, the project objectives of the water resources design will be to capture stormwater runoff that is generated on site. That runoff will be put into systems that will improve the general water quality, as well as remove 50% of the total nitrogen and control flooding. For alternative 1, this completes the objectives by placing rain gardens on each side of the main development area to capture runoff as soon as it flows off of the site. These rain gardens will improve the water quality as well as remove nitrogen by allowing the water to infiltrate through bioretention media. The flood control volume will be controlled by dry detention basins attached to these gardens. The benefits of this design is that it increases the aesthetics of the area by adding a lot of vegetation around the parking lot as well as the buildings. The downsides of this alternative is that it lacks a form of pre-treatment, which means that larger solids will not be filtered out before entering my drainage systems, which means that the systems will clog more often and require more maintenance. Another issue with this design is that it doesn't use the land as efficiently as it could, because each system is only handling a portion of the runoff. For alternative 2, vegetated swales are used to transport the runoff to the east to be captured by separate systems. Alternative 2 uses sand filters to improve the water quality. The downsides of using sand filters, however, is that they are aesthetically unappealing, and they are also a poor source of nitrogen removal, since the majority of total nitrogen is not removed through filtration. Alternative 3 features a rain garden integrated into the building design of our structural 1 engineer, which will capture the runoff landing on the roof of the building, as well as increasing the aesthetics in the building itself. This design also uses vegetated swales to transport the vast majority of runoff to the east to be handled by a rain garden detention basin on that side. The benefits of this design are that it is extremely effective in both land use and cost, because it has the smallest total footprint of any alternative and also the lowest number of total systems used in any alternative, which will definitely be reflected in the cost. This design is also very good because it leaves the area between the football field and the buildings to be open for future developments. Alternative 4 uses pervious pavement on the parking lot as well as gardens on the tops of the buildings. This will reduce the total amount of impervious area on the site, which will greatly reduce the total amount of runoff volume that will need to be captured by alternate systems. This design also features a pond that will handle the flood control volume. The downsides of this alternative is that it is very expensive due to the large amount of surface area needed to be covered by the pervious pavement and the rain gardens. It's also over-designed just because specifically the rain garden or the rooftop gardens and the pond will be able to handle a much larger volume than they will need to be. And ultimately, this design is also impractical just because of the large amount of open area that is available to be worked with. So we don't need permeable pavement, we have extra area to implement other systems. In this table, you can see the criteria by which the alternatives were evaluated. This includes the effectiveness, which measures the design's ability to complete the project objectives. It includes cost, land use, maintenance, and aesthetics, with effectiveness and cost being weighted the highest. You can see I've graded all my alternatives using these criteria with the higher score means that it did better. As you can see, alternative 3 received a perfect score because it's handled each of the criteria better than any of the other alternatives. The other 3 alternatives received lower scores due to the reasoning that I previously mentioned. So, like I said, alternative 3 was chosen. Below you can see the total construction cost that was estimated using RS means and unit pricing. The total came out to just under $74,000. Here you can see the future work that I will need to do next semester, which includes the rain guard design, nitrogen removal design, culvert design, outflow design, and the cost estimate. And from here, I will hand over to our structural 2 engineer, Aubrey.
Thank you, John. As the structural engineer, my objective is to design an academic building for Valparaiso University that will be located where the yellow rectangle is on the image above. This building will span 25,000 square feet, 2,000 of which will be for indoor multi-use area, and the rest will be for classrooms and laboratories. To recap my alternatives, my first alternative is a 1-story reinforced concrete building with the indoor multi-use in the front and center of the building, which will be consistent throughout all of my alternatives. The member layout was decided based on reinforced concrete and moving a couple of things around to fit the indoor multi-use area. For alternative 2, this is a 1-story steel structure with the same floor plan as alternative 1, since they're both 1-story. And the member layout is a little bit different as the material is different in these 2 structures. For alternative 3, I have a 2-story reinforced concrete structure. The member layout is very similar to my first alternative, as they are both using the same material. And the floor layout is a little bit different because there are 2 stories. However, the indoor multi-use area is still shown at the front of the building. For my evaluation, I used cost as my most important parameter because we would like to use the client's budget respectfully and in hopes of being entrusted with future projects. For my next parameter, I used constructability weighted at a 3 because we would like this building to be constructed in a timely manner and an efficient manner for the citizens of Valparaiso's convenience and the client's convenience. Then I rated aesthetics at a 2, as we would like for the community not only to benefit from the usage of these buildings, but also from the looks and the aesthetics of the building. Lastly, space efficiency was weighted at a 1, as we would like for the floor plan to be easily navigatable and also for there to be room for future developments in the area. For my scoring, I ended up giving the first alternative a 1 in cost because it was the most expensive, decided by RS Means square foot estimator. For my second alternative, it received a 4, followed closely by my third alternative with a 5, as these are both very close in cost, but the third alternative was slightly less expensive. For the next parameter, for aesthetics, we had deemed that concrete would be less aesthetically pleasing than steel, so both of the concrete structures got a 3, while the steel structure got a 4. And for space efficiency, the 2-story building uses less square footage than the 1-story building. However, they both have very easily to navigate floor plans. So the concrete 2-story building received a 5, while the other 2 received 4s because either way, neither building is taking up too much space as to where there would not be room for future developments. Lastly, for constructability, the 2-story building received a 1, as a 2-story building is more difficult to construct than a 1-story building. The concrete 1-story building received a 3, and the steel 1-story building received a 5, with the final chosen alternative being the steel 1-story building with a score of 43, which is the highest score. My cost analysis, as previously said, was decided by RS Means square foot estimator, and it ended up being around $5.8 million. Lastly, for my future work, I'm looking forward to delving further into this design and looking at individual member design along with floor and roof layout and foundation design. And once I get all of those figured out, I can come up with a more accurate cost estimate. Speaking of cost estimate, for our design cost, we have used our work breakdown, the hours from our work breakdown structure, multiplied by our hourly wage, and used a 15% contingency to receive a total design cost of almost $86,000. As for our construction cost, we used our chosen alternatives, and for both structural and water resources, we used RS Means. For transportation, we used NDOT unit price summary, and for the demolition, we used NDOT unit price summary for the demolition of Dove Drive and the RS Means for the demolition of existing structures, to get a total rough construction cost of $18.5 million. Thank you. Does anyone have any questions?
Your construction cost is kind of low. What did you use for the estimate?
So that was using the RS Means unit pricing summary. That also only includes like the actual construction. It doesn't include any labor or anything like that. What I factored into that construction cost was the excavation of the total volume I needed, plus seeding costs for the area required for vegetation, as well as drainage piping. So once I know more details about the final design, that cost might change.
So I have a couple questions, I guess two. One is on the culvert side. So there was a picture of the culvert. Can you let me know a little bit about the dimensions of like what you're going to span and the depth that you're going over?
Right, so I will just need to span the entire roadway as well as some clearance on both sides due to the side slopes and everything. I don't have an official dimensions yet, but I know the volumes that I will be dealing with. So next semester, part of my future work will include figuring out the final designs and dimensions and everything.
Right. I think on the transpo side, right, you had a sketch. Just review. There you go.
Yeah, right there.
So can you give me an idea of like the dimension or the scale of it?
So I'm not also exactly sure, just because we know that we need 2 feet above the culvert just for over the roadway, before the roadway. So then underneath that, the specific dimensions will be brought to our attention once we do a more in-depth search on what the culvert dimensions.
Okay. And then also with the roof gardens, I think on the water side, you mentioned that they would capture water for a little while. How, maybe on the structure side too, how are you determining the loads for those?
Well, I didn't determine anything that in-depth, just because I knew that that alternative was not necessarily practical, so I didn't determine the exact loadings and everything. But if I did move forward with that alternative, I would have had to do some more calculations with that kind of thing. I probably just would have used the like densities of the soil I intend to put on there and just try to figure out the dimensions best I could.
Okay. I mean, well, usually a green roof is going to drain normally, right? So it won't accumulate, unless you design it to accumulate like a pool of water.
Right.
It shouldn't, right? It should kind of let it drain out.
Okay.
So, but there's a big difference in the loads then, if
Okay.
you're making kind of an artificial pool.
Right.
when it rains. All right.
Mr. Schiegel?
A question on this slide, Mackenzie, this road is new, right? So how do you know how many cars are going to use it?
So I did do trip generation, so it is using the transportation manual. You can estimate, so with 2 buildings, you do retail, you find the square footage of that to determine the number of trips. So for the academic building, you figure out how many students will be there. So I calculated on average how many rooms Aubrey will have in her building, and to discover how many students there will be for that one. In the retail, there is for the square footage of the building, it does give you per square footage how many cars they think there would be. And then when I did the Boilermaker with the connection, it also included all of the buildings back there to discover how many trips we think will be taken on this new road. Any more questions? Thank you.